Hi there grade 8s and welcome to WorksheetCloud Maths once again. I hope you're all well today and you have open minds to learn a lot because I really enjoy teaching you and I hope you enjoy learning as much as I enjoy teaching. Today we're going to have our next lesson in measurement and remember the last lesson we learned how to use Pythagoras' theorem. So today we're going to put that into practice. Okay, so here we go. Just got to go over the theorem of Pythagoras. What does that state? It states that in a right angle triangle, the sum of the square of two sides is equal to the square of the hypotenuse. And remember, the hypotenuse is the side that is opposite the right angle. So as you can see there's the right angle in the corner and the hypotenuse is opposite. If we were to turn this around, and the triangle was the other way around, the hypotenuse would be over here and the right angle would be over there. But not to worry about that, you just need to look at how the diagram is positioned, find the right angle, and then you will find the hypotenuse. Okay, so just to go over the theorem again, we did prove it in our last lesson, but it is to say that in a right angle triangle, remember it needs to be a right angle triangle, the sum of the square of two sides is equal to the square of the hypotenuse. Okay, right. So we are going to use this and apply this theorem to solve some problems. So let's look at our first problem. Tia is on her way home from work. She drives 9 kilometers due north and then 4 kilometers due west. Find out what distance she would travel if there was a direct route. And you need to round off your answer to the nearest kilometer if you need to. Okay, so let's first of all use a diagram to represent the problem. It's very often a good idea to draw a diagram when you're trying to sort out a problem because it almost sorts it out in your mind, and when you see it visually you can actually see what's missing and what you need to do to calculate, to get to the answer, to calculate the answer. Okay, so let's draw the diagram about Tia going home from work. All right, so the first thing is we've got work and she drives due north. So that's straight north, okay? And that is 9 kilometers, right? From there, it must be a T-junction or something like that. And she turns and she drives due west. And so that is going home. That's going to get her home. And that distance is 4 kilometers. Okay, everybody can see what's happening? All right, so what we have to work out is if there was a direct route, how long would that direct route be? What would the distance be if it was straight? So first of all, where our due north meets our due west, it forms a right angle. As you can see there, I've put in the little right angle sign because it says due north and then due west, which means that it's straight up to north and straight along to west. Okay, so we are now going to have to measure the distance if there was a direct route. In other words, she didn't have to go to the T-junction. She could just cut straight across from work to home. Okay, and that is the shortest distance. So obviously we need to work out the shortest distance that it would take her if there was that option. So what are we going to do? As you can see, that is a right angle triangle, which means that we can use the theorem of Pythagoras to actually work out that shortest distance. Okay, right, so what does the theorem of Pythagoras say? It's c squared is equal to a squared plus b squared, and we need to put in our reasoning because we can't just say, okay, well, we've just got that from somewhere. We have to say that that is because of the theorem of Pythagoras, which we've already proved that it works. So we can use that as a reasoning. So you don't have to write out the whole thing, theorem of Pythagoras. You just need to write their Pythag, and your teacher or whoever is looking at your work will know exactly what you're meaning and where you got it from. Okay, so c squared is obviously the shortest distance, and we don't know that. That's what we are trying to find out. So that would be our hypotenuse. Remember, it is directly opposite the right angle. As I said in the, or just now, earlier when we looked at the other diagram was the other way around and the right angle was down at the bottom. And I said to you, look for where the right angle is. Opposite the right angle will be the hypotenuse. So the shortest distance is actually the hypotenuse that we need to work out. All right, after that long explanation, c squared then is equal to 9 squared plus 4 squared. Can you see there's the 9 squared, 9 for the due north, and then the 4 for the due west. Okay, so we work out 9 squared, that's 81. 4 squared is 16. So we've got 81 plus 16, but remember that gives me the hypotenuse squared. So the hypotenuse squared will be 97. Right, everybody got that? 81 plus 16 gives me 97. Now I have to square root 97 to get what C actually is, what the value of C is. And remember it said round off your answer to the nearest kilometer. Please remember to use your calculator here and then round off on your own. Okay, so 97 square rooted would give me 9,85. It does go on, if you look on your calculator, round it off to the nearest kilometer would give us 10. Okay, so the answer here would be 10 kilometers. If she were to travel a direct route, if there was a direct route from work to home, she would be traveling 10 kilometers. Okay, so what I did first was that I rounded it off to the nearest second decimal place, which is the general rule of thumb. That's what you should do so that you're not carrying on and on and on with decimal places. So it was rounded off 9,85. If you're rounding it off to the nearest kilometer, it would give us 10 kilometers. Right. Okay, let's look at our next problem. Apply the theorem to problems again. Next problem is a 4,5 meter tree casts a shadow that is 2,4 meters long. What is the distance from the top of the tree to the end of the shadow? Again, trying to visualize it in your mind can be quite difficult, so I've got a little picture for us to use, but just remember you don't have to be an artist and actually draw the tree. I have got one for you. Let's use the diagram. There's the tree and you can see the shadow. Okay, so the height of the tree is 4,5 meters. We're told that the tree is 4,5 meters. Okay, so that's to the top of the tree. And as I said, we were told that it's 4,5 meters. The shadow is going along the ground, and that is 2,4 meters from the tree to the end of the shadow. Okay, now in the corner, it creates a right angle where the tree and the shadow start creates a right angle, which means that, as you can tell, we are going to be able to use Pythag again. So the question asks, what is the distance from the top of the tree, as you can see there where the top of the tree is, to the end of the shadow? So we now are going to draw in that line on our diagram so that we can see exactly what we are working out. Okay, all with me. So again, we're going to use c squared is equal to a squared plus b squared. C squared is our unknown distance. It's the distance from the top of the tree to the end of the shadow. So it's unknown. Okay, we are given the height of the tree and we are given the end of to the end of the shadow, the length of the shadow. Okay, so c squared, we keep c squared and we then put in our other measurements, and it's 4,5 meters all squared plus 2,4 meters all squared. Remember, the reason that I'm putting it in brackets is so that it's not just the meters that are squared, but it's the number as well. It's the actual measurement that is squared. Okay, so again, guys, use your calculator to work out 4,5 times 4,5. If you have to do it on a piece of paper, that's absolutely fine, but it does make things a little bit easier if you use your calculator. Right, so we've got 4,5 times 4,5 is 20,25 meters squared. Then 2,5 meters all squared gives us 5,76 meters squared, and you would have worked that out on your calculator. Add those two together, you're going to get 26,01 meters squared, and remember that is giving us c squared. So that gives us the unknown distance, but the square of it. So what do we have to do? Absolutely right, we have to square root it. Okay, so if we square root 26,01 meters squared, it will give us 5,1 meters. Okay, so that means the distance from the top of the tree to the end of the shadow is 5,1 meters. Everybody happy? Okay, it always helps to draw a diagram, guys. So like I said, your diagram didn't have to have an actual tree in it. You could have just drawn a representation as a line. If you needed to, you could have labeled it tree, but you know what you're doing. So it's absolutely fine just to draw a line and draw the line of the shadow and then figure out actually that when you join the two, it forms a hypotenuse. And voila, we're actually dealing with a right angle triangle, so we can apply Pythag. Okay, let's carry on. Let's look at another problem. Okay, I tell you what, why don't you try this one on your own? I'll read it through with you. Not that you really need me to, but I'll read it through with you. Then you pause and you try and figure it out on your own. And then when we come back, we'll go over it together. Right, so Rachel bought a rectangular rug for her house. Can you visualize that, a rectangular rug? The rug is 3,35 meters long and 2,4 meters wide. She wants to cut it in half from corner to corner so that it will form a triangle along one wall. Don't know why you'd want to do that, but never mind, Rachel wants to do that. If she wants to put the cut edge against the wall, how long would the wall need to be? I must say, guys, I can't imagine really buying a rug and then wanting to cut it in half, so Rachel must have lots of money. But anyway, that's not the point to this problem. So let's have a look. Okay, first of all, pause the video and you try and work out this problem, and when you come back, we'll go over it together. Right, are you ready to go over it? Let's have a look. So the first thing, we should draw a diagram to represent the problem. Okay, so there's the rug. Again, you are going to probably just draw a rectangle. It doesn't need to look like an actual rug. Okay, it's a representation. Okay, and we're going to put in what we know. So we know that the rug is 2,4 meters wide and it's 3,35 meters long. Okay, we are told that. So now Rachel is going to cut that rug diagonally from corner to corner because she wants it to be in a triangle for whatever reason. Okay, so we're going to draw in the cut where she's going to cut. And we don't know that length. So she wants us to work out that length so she knows which wall she can put it against. Okay, in the corner of the rug, because we know it's a rectangle, there is a right angle there. So we know we can use Pythag. Right. Okay, so just remember to look for that. Sorry, that sounded like a bit of a mumble. Just remember to look for that when you are dealing with a whole lot of different things and you're not just doing the section on Pythag, okay, because at the moment that's what it all is all about. All right, so we've got, again, c squared is equal to a squared plus b squared, the hypotenuse being the c squared. Okay, so we then are going to have to substitute in a and b for the measurements that we are given there. So a, 2,4 meters, all squared, plus b, which is 3,35 meters, all squared. Use your calculator and multiply those, or you would have used your calculator to multiply those. You end up with 5,76 meters squared plus 11,22 meters squared. Add them together and you get 16,98 meters squared. But remember, that gives me c squared. I want to know what c is on its own. So c is equal to the square root of 16,98 meters squared, and the square root of that is going to give me 4,12 meters. Okay, and that is your diagonal of the rug. Right, so the wall that she needs to put it against will need to be no shorter than 4,12 meters. Right, maybe her flat or her house, the room in her house is not completely square, and so she thought that this would work better to have half the rug. Right, everybody happy with this so far? Okay, so these have been word problems that we have dealt with. They are routine word problems, but nevertheless they are problems that we needed to work out. We are now going to go on and look at how to solve geometric problems using this theorem. Okay, so the first one is fairly simple, not too difficult at all. So we're going to look at the diagram and work out the length of AD in the triangle. So there's our triangle. We are given the measurements of AB being 12 centimeters, DB being 6,7 centimeters, and that's all we really need, because we don't need to work out AC. That triangle, the basic triangle ABC, is not a right angle triangle. So if we weren't given the perpendicular height, we actually wouldn't be able to use Pythag, and I'm sure you all understand that. Okay, we need to work out AD, that part of the triangle, which is actually part of the base in this case. So if we're working out AD, it's not the hypotenuse. The hypotenuse is AB. Okay, as you can see here, the hypotenuse is here because this is where the right angle is. So the hypotenuse is directly opposite the right angle. Okay, so let's carry on. AB squared is equal to AD squared plus DB squared, and that's because of the Pythagoras theorem. Okay, so we can just put Pythag in there. Right, we don't know, oh sorry, we do know what AB is. It's 12, so it's going to be 12 centimeters squared. We don't know AD, that's what we're trying to work out, and DB is 6,7 centimeters. That's why I say, guys, you must always use your calculator, because 6,7 centimeters is an odd length. So to work it out on the calculator just makes it so much easier. Because remember, at this stage, you're not being tested on your actual calculations. You're being tested on the process. All right, but let's get back to this. So we've got AB squared, which is 12 centimeters, all squared. AD, which is our unknown, plus 6,7 centimeters, all squared, because that is our perpendicular height. Okay, and that is where the right angle is created, from the base where the perpendicular height meets it. Okay, right, 12 centimeters all squared gives me 144 centimeters squared, plus AD squared, which again is our unknown, plus 44,89 centimeters squared, because 6,7 times 6,7 gives me 44,89. And guys, if you also are a little bit worried about whether you are in the right ballpark for your squaring, remember 6 squared is 36, 7 squared is 49. So 44 is between the two, and 6,7 is just over halfway between 6 and 7. So it sounds about right. Okay, if you had 144 there, then you would go, my estimation, that cannot be right, because it's got to be between 36 and 49. Okay, so it's always good to check those things, because then you can tell straight away when you've made a mistake and not get right to the end of the problem and then realize you've made a mistake. Anyway, let's get back to this. I now use my algebraic knowledge and I take my 44,89 across the equal sign, which means I have to subtract it. So it would be 144 centimeters squared minus my 44,89 centimeters squared, and that is going to give me AD squared, which is what we're trying to find out. So if I subtract those two, I end up with 99,11 centimeters squared. Remember, I need to square root because I want to just find AD on its own and not AD squared. Okay, so if I square root 99,11 centimeters squared, I'm going to end up with my answer for AD. Okay, so let's square root that on the calculator, and I get 9,96 centimeters, and that is going to give me AD. So that is the measurement for that part of the base of this triangle. Okay, so like I said to you, we can work in a triangle. I think I said it to you last time. We can work in a triangle that is not the whole triangle is not a right angle triangle, but we need to try and make sure that there is a right angle somewhere, and we are given the measurements. Okay, so let's go on and look at another one. There's another geometric problem. This one is a little bit more involved. What I think we should do is you have a look at it, pause the video, see if you can figure it out for yourself, and then we can go over it together. So let's have a look. We have to find the length D in this rectangular prism. And I'm sure you're going, rectangular prism, how are we going to use Pythag in a rectangular prism? But let's have a look at the diagram. Right, we've got the diagram there, we've got the measurements there. I want you to try and work out the length of D. So Pause the video, see if you can work it out. A hint would be to give the corners or the vertices names, okay, as in letters, right? But you try and work it out as best you can, and when we come back, then we'll go over it together. Right, let's see how you did. Okay, I've named my vertices or corners A, B, C, D on the top rectangle and E, F, G, H on the bottom rectangle. Okay, now we know this is a rectangular prism, so there's some things that are given in a rectangular prism. In other words, all the breadths, so the 5 centimeters, are all going to be equal. GF is equal to HE, which is equal to DA, which is equal to CB. But if we use that in this explanation, we've actually got to state that they are equal because of it being a rectangular prism. Because the fact that it is a rectangular prism is important because we know the properties of a rectangular prism. Okay, and it's the same with the heights and the lengths. So HG is equal to EF, which is equal to DC, which is equal to AB, if we need that. Okay, the heights are also the same. DH is equal to CG, which is equal to BF, which is equal to AE. We need to familiarize ourselves with the actual diagram and look at it very carefully before we start just going ahead and working it out. Because if we do that, we sort of orientate ourselves with where we are, what we need to go, what we know, what we need to get to, and eventually how to get the answer. So if we look at this rectangular prism, we can see that we know nothing about D, okay? Other than we would know that AE is the same as DH. That's all. That's just the one side. But we also do know, because it's a rectangular prism, AE meets EH and EF at a right angle. So shouldn't we also try and figure out, first of all, what EG is, because EG is also one of the sides to the triangle that we are trying to find the hypotenuse for. Okay, so if we wanted to work with that, if we needed to work out EG, we would have to work out what the diagonal of that base rectangle was. Now you can either work it out using the length EH, or you can work it out using the length EF. Both of them do not have measurements written on, but because this is a rectangular prism, as we went over just now, we know that EF is equal to HG, which is 12 centimeters, or EH is equal to FG, which is 5 centimeters. Either way you work it out, you are going to get the same answer. So let's see. Right, we've got EF is equal to 12 centimeters, so I've used EF here, which is equal to 12 centimeters. Why? Because EF and HG are equal because they are opposite lengths in a rectangular prism. Do you see how we use our reasoning? We can't just write it down, we've actually got to say how we came to that conclusion. Right, the next thing we're going to do is we're going to work out EG, because that's important for our next triangle that we have to work with. So EG happens to be our hypotenuse. So it's EG squared is equal to GF squared, which was given as 5 centimeters, and it's equal to GF squared plus EF squared. We've worked out EF is 12 because it's opposite lengths in a rectangular prism. We're given that GF is 5. So obviously we're going to go 5 squared plus 12 squared. Okay, and it's 5 centimeters all squared plus 12 centimeters all squared. Just remember again, those brackets are there because we're squaring the whole thing, not just the centimeters squared. If we wrote it 5 centimeters squared, it would seem like the measurement has actually been squared already. Okay, so 5 centimeters all squared gives me 25 centimeters squared, and 12 centimeters all squared is going to give me 144 centimeters squared. Right, so EG squared is equal to 25 plus 144. That's going to give me 169 centimeters squared. Remember, that's EG squared, so it's the diagonal squared. We want the diagonal on its own, not the square of it. So which means we have to square root 169 centimeters squared. and that's going to give us the length of EG. And as you know, 169, the square root of 169 is going to give me 13 centimeters. Right, now I've got this measurement and I've got that measurement, which means I can now work out what D is. Okay, so we're going to end up, let me just move. AE is equal to 7 centimeters. Why? Because AE and DH are equal because of opposite heights in a rectangular prism. Okay, that's your reasoning, how you figured out that AE is equal to 7 centimeters. So now we've got the 7 centimeters and we've got 13 centimeters. Let's work out D. So D squared is equal to AE squared plus EG squared. D squared we are working out, so that we can leave there, and AE is 7 centimeters and EG is 13 centimeters. So 7 centimeters all squared gives me 49 centimeters. 13 centimeters all squared is going to give me 169 centimeters squared. We're going to add those two together and we end up with 218 centimeters squared. But remember, we can't leave it like that, so we need to square root the 218 and we end up with 14,6 centimeters squared. So D is 14,76 centimeters. Okay, so guys, that was quite a roundabout way, and I hope you all did well and you could all see exactly where we were going to work that out first and then that out, because we are looking at different triangles. First we looked at that triangle to work out that length, and then we had to look at this triangle to work out that length. If there's been anything that you have been confused about, please don't hesitate to send in your query or your question to grade8@worksheetcloud.com, or alternatively go back to the beginning of the video and watch it step by step, and stop it when you need to and try and understand what's going on and then carry on. Alright, so we dealt with a lot of problems today and they were all with regard to Pythag, and so when you are dealing with a word problem or a geometric problem, look for things that may relate to the Pythagoras' theorem. Okay, thank you so much for watching today. I hope you enjoyed it as much as I did, and I will see you next time. Please keep well and keep safe, and I can't wait to see you again. Bye bye for now.